Okay guys, so let us start today. Today's is the first experiment where you will mesh an Aerofoil. So first go to workbench. Once you're there, what you'll do, we'll do sidewise. We'll search for the Naka data file. So click on Naka 0012 data file. Go to your first result. What you do, you download that file. So you need for data points. So click on save as. Already done few samples, so just save it in another place. So check it as downloads. Okay. So here also it was Naka 0012. Save it. Open that file. You can erase all of this and then copy the whole file. Copy the whole file. No, don't copy it. Just save it. Come to your Excel. Okay. In here, go to data. From text. Save it in downloads. So downloads. This is your Naka file. Import. Keep it as fixed width, that is giving two different columns for two different data. Okay, so now finish. You want it in C, so click on C. So here, don't do this plus, just take equals. Okay, now we've imported that. Now what you do, there is one empty column in here. Go and delete it. And then next what you do, first column, you take it as 1, 1, and then expand it throughout. And then the next column, you take it as 1, 2, then expand it. So yeah, one is just the file name, so one file, and this is just the serial number. And the next one is your X coordinate, Y coordinate, and Z coordinate. Everything is 0, and then expand it onto Z coordinate. What you do, the last data in here, make it 0. Okay, so make it 0. Then what you do, copy the whole thing and paste it in your notepad, original notepad, wherever you have come. Now what you do, just make this slight arrangement. That is, arrange these zeros properly. Here is 1, 0. Here is 1, 0. This one, I'm using tab. Okay. There's one more 0 here. So arrange this 0 and then save it. Save it as the same file. So once you've saved it, then close that. Come back to your workbench and then go to fluid flow fluent. From this column analysis system, not here, there is one more fluent here, don't go here. Fluid flow fluent, drag and drop, and right click. For higher versions, there is something called new space claim geometry. For lower version, it is not there, but you need design modular. Go and click on design modular. Wait for a second. Once you go, click on create points, and in points, go and search for your file. That is Naka 0012. Insert and generate. Once you've done it, you've got your Naka data points. So once you've got your geometry, you can click here, zoom to fit, so to show what all is present. Then you can use your scroll to zoom in and zoom out. Okay, and then here is your views, however you want to see it. If you want to see from z-axis, see from z-axis, and top view y, side x, and ISO. Just click on this ball thing and come to your front view. Once you come to, and here you can use this tool to move however you want it. And here, if you want to zoom in on any portion, you have to zoom in here. And if you want to zoom out to fit and rotate, okay, there are some basic options here. Okay, work it out. You need some practice to get the hang of it. To do practice. So now what I'll do, I'll zoom in, but come to this portion. Go to concept, lines from points. Now click on the first point and then hold control, click on the second, and then the same point, so on. Okay, so like that. You'll join all the points. Just hold control and click on two consecutive points. Okay. A little time consuming. Okay. And then, I mean, it doesn't matter how you start, just join all of it. There is an option in the data file that you can reduce these points, but you can reduce this to 50 points and then you can join it. But for higher accuracy, the greater points, the greater number of points, the better. Okay. Now zoom out. And you can zoom in at this portion wherever you're left out with. Okay. And then here, see, once you have taken this option, your icon is now on zoom. So to get back to your point, click on point selection, and then again hold your control and join the remaining points. Zoom out. And this point is not connected. Okay, now done. So click on apply. 131 points. It's all of them connected. So you can see one blue line has formed now. Okay. Now go to concept. Sorry, click on generate. So it's generating. You can see the status of your or the progress of your file or whatever you're going ahead with here. Just wait for that to clear. Once that is clear, you can proceed further and don't press multiple times anywhere. And you don't have a normal control Z option, like an undo option here. So sometimes it doesn't really work out. So just be patient, go to concept. What you do, you take the option surface from edges. Okay. So from edge, you'll be creating a surface. So again, same thing, click on this and now select, so this edge selection, hold control and click on all the edges that you have created. Now take further zooming, zoom it in here, edge selection, select all the thing, apply 131 edges, and then generate. So you can see once you have completed, you can see a grayish color being imparted. That means the surface is created. Once you're done with it, you have to create a domain across the geometry. Now what you do, go to sketching. So sketching would have begun at, so this is the line, what you're seeing is your Cartesian line, or your Cartesian system of line. So that is 0, 0 here. So what you do somewhere here, you just draw a box like this. And then, so rectangle, I took rectangle in sketching. And then go to dimensioning and try to give the dimension to it. So horizontal distance, sorry, vertical distance from this line to this line, take it as 2 mm. Okay, and one more distance you need to specify, that is from this distance to the horizon line of x-axis is 1 mm. Okay, and now the horizontal distance from this line to this line is 4. Take it as 4. Okay, once you've got this, know this whenever you draw something, let us say, so this is your airfoil, the front side of it should be at least 25% of the overall body. So 4. So 25% of 4 is what? 1. So somewhere between 25 to 30% you can take. So I'll take the horizontal distance from here to this line as 1 mm. Done. And now your boundary or the boundary of observation is defined. Okay. So once you define it, go to concept, surface from sketch. You take sketch because this is a sketch what you drew. And now click on the sketch. That is your line sketch. Apply. I missed it once. No, so here is your sketch. Sorry. XY plane, sketch 1, resist, apply, and generate. So I think I took a wrong option. Did I take surface? I'll just delete this. Concept, surface from sketch. Okay, I think I've taken a wrong option. So just surface from sketch. Click on the sketch, apply, and generate. Okay, now you have it. It is gray. I mean, colorful. So once it is colorful, that means the surface has been created. So you need to subtract it. For subtraction, go to create, Boolean, and in Boolean, you need to take the option unite is to add and subtract to subtract. Target body is your domain, apply, and the tool body that you want to subtract is this one. Okay, so if you're a bit confused here, what you do, you can just click on here. So that is your surface body, apply, and then generate. So once you generate, this is your hole. Or why do you have hole here? That is, this is the surface. This whole thing is surface, and this will act like an obstruction. Okay, that is why you are creating a hole there. Once you're done with this, you'll have to name the bodies. Okay, so first one. So first you go to tools, and then click on name selection. Click on edge. This edge is your inlet. So name it as inlet. Okay, and then select the edge, apply, generate. Done. And again tools, name selection. Again, see this now surface being selected. Click on edge selection. Click on this edge, outlet. Click on the edge and apply and generate. And now we need to make a wall. Okay. Name selection, wall, and the walls are in edge selection, this one, and this thing itself. So what you do, there is no any control A sort of thing. Yeah. So clicked on control A, deselect these two. Okay. So the remaining everything is wall. Apply. So you totally have 264 edges, and then generate. So just go back to your name selection and cross check. So that will highlight. See, inlet is highlighting, outlet is highlighting, and then wall is highlighting. Okay. So once you're done, you can close this. Now click on mesh. Once you click on mesh, the mesh module will open. So wait for it. What we're doing is an unstructured mesh. Unstructured as in you want the computer to create the mesh for you. So come to mesh. So once you come to mesh, there are different options, however you want to see. But for this experiment, you just want to generate one sort of mesh. But you do explore with this option. Go to sizing. That is your mesh sizing, how much you want to keep. And here you have many options: adaptive, proximity and curvature, curvature, proximity and uniform. So these three is just giving the priority how you want your mesh to be. For this experiment part, we just need adaptive. And here we'll have to select coarse, medium, and fine. Take medium. And element size is the element, what is like the basic unit of mesh size that you want here. So for it, I'll just take one now, and then we'll update and see how is our mesh. Just wait for it. So see, this is a minimum of 1 mm length. Okay. So let us see. Let us take the value 0 and then see how it is going to update. So take 0 and update. So what you saw was the minimum length is 1 mm. So now you see this is your 0 is the smallest possible value that can take. Okay. Now let us say I will take proximity and curvature. So this is an adaptive length. Adaptive is like depending on the geometry how the surrounding is, it will try to mesh in that form. So go to your proximity and curvature. So proximity is nearby and how curved it is. Okay. So it has just meshed, but it has not taken the element size here. Correct. So you can define it here: maximum face size or minimum face size. You can just you guys just explore a lot of this, and we'll see curvature dominant. Okay. So it is mainly focusing on the curvature. You can see on the corners, there is no much deviation. Okay. And then now next you can take the other one, uniform, or no, just proximity. Proximity, update. Okay. A similar mesh generation, and go to uniform. Let us see how it will come in uniform. So uniform is trying to keep as uniform as possible. Okay. But you see, if this is generated like this, the true shape of your airfoil that is here is not taken into account. And this will lead to a bad result. Okay. But you can try to reduce the size, and then let us see. I'll just, is there any, I haven't worked out on this much. Okay. You guys check it out. It's okay. Now for your experiment, take adaptive, and here course, you take it as fine, and then update. This is how you want it. So this will give you the maximum way you want it. Once you've got this, you can further refine or make it better adjustments. So go to mesh, insert, click on refinement, and then select your surface, click on here, apply, and then generate mesh. Okay. So once you generate, click on the mesh, you can see it is further, it is further try to refine it in a better way. Okay, so this is your unstructured mesh.